Hello guys, in this tutorial we will learn how to launch OpenFoam in serial and parallel modes. The roadmap of this tutorial is presented here. Objective. The main objective is launch the standard tutorials in serial and parallel mode. I have selected lead-driven cavity simulation for this purpose. First step is install the software. I am using Windows 10. So I have to install Windows Subsystem for Linux and OpenFoam. So the installation link is provided here. One can browse through this link and follow the procedure. For Ubuntu followers, the download link is provided here. This is the first step. I have already done, so this is not included in this tutorial. Next step is serial simulation. Here, first step is copy the tutorials to any working directory. Create a working directory, then browse through the tutorials folder of OpenFoam and copy the folders 0, system and constant of lead-driven cavity tutorial and save in the working directory. Now open the Ubuntu terminal and set the path to the working directory. Now one can launch the simulation using the commands blockMesh and icoFoam. BlockMesh is to create the mesh and icoFoam is to launch the OpenFoam solver. Once the simulations are done, the post-processing can be done. The next step is parallel simulation. In parallel simulation, we need to make small changes. The first change is in the folder system, we need to add a file. The name of the file is decomposeParDict. This file is available in other tutorials. You can copy from there or you can directly create and write the matter here. The matter is written here. So in this file, you will see number of subdomains 2 or 4, whatever. So this matter is to be written in this file and saved. Once this is done, now one can launch the simulation using the following commands. The first command again is blockMesh to create the mesh, then decomposePar. It decomposes the case to be run in parallel. So based on the number of subdomains listed here, the decomposition will be done accordingly. Once this is done, then use the command mpirun to launch the OpenFoam solver in parallel. Once the simulations are done, use the command reconstructPar. So this command reconstructs all time steps of the specified case and saves in the corresponding directories. So once this process is done, we can load the results in ParaView and carry on the post-processing activities. We will see further how we do this. So the Windows subsystem for Linux is installed here. Then I will click here. So we go to OPT folder. Here OpenFoam is installed. So I have used installed OpenFoam version 2012. So in this you have tutorials. Go to incompressible, then icoFoam cavity. So these are the 3 folders which we need to copy from here. Copy. And then we go to, we'll create a new working directory here. Simulations. And here I'll write cavity serial. So I just copy the paste the files here. Now in this folder we have pressure and velocity parameters. We can open this and check. So this is the boundary details are given here. And same as the case with U. And then in the constant folder you have transport properties. And in the system, you have blockMeshDict and control. We don't generally test these files. We may need to open this and modify this control dict. This gives you, the end time, the number of results you need, all these details are to be updated here. I don't want to change here anything now, but you can modify the end time, the frequency of the results, dumping, and all other details. So now we go open the Windows subsystem, and then Ubuntu terminal, then we go set the path to the working directory. We see see. So here, yeah. Now from here, we have to create the mesh using the command blockMesh. So once this end is done, that means the meshing is done properly, then we launch the OpenFoam simulation. icoFoam. Yeah. Now the simulation is going on and it is done. We may change the parameters once again. So it's 4.5. I'll delete these files. I'll go here and open this file again. Then I change this to end time to, let us say, 5. Delta T will not change. Interval I will set to 10. And I will not change anything else. So then close it. Come back. So here if you want to launch, firstly you may delete this polymesh folder or you may keep it. Then I'll go to blockMesh. The machine is done. Then I will launch the simulation. You can see the simulation is going on. You can check the residuals and other parameters here, like time step continue errors. They should be very less value, like 1 equal minus 9 or 2.8 or minus 9. This is very important. Here, if the values are wrong or they are plus here, let us say 7.68 plus equal 9. So the simulation has gone wrong somewhere. So the file time step is done. So now these are the results here. Now to check the results in post processor, what we do is we go to 0 folder, take any file and just paste outside and rename it as anything paste.4. Now you can open the ParaView. Simulation cavity, so you can see case.foam. You just open it. So here you can see the pressure and this is a simple mesh. So I create a slice here. J normal, apply. Velocity is here. So you see the contours in a much different way. Click here and take turbo or any other option and apply it. So this is the simulation. And just play it. So once done, we'll go to parallel simulation. So again, what we do is we'll copy the 0 folder and the other two folders and create a new folder, gravity, parallel, all this sheet, delete this one. Now, set the path to the other folder. Then again we use the command blockMesh first. Meshing is done. Then now we need the new command. A new file has to be created here. So let me get the file first. So this is the file which we need. I copy here and go back to the working directory, parallel, and I keep this in the system folder. Open this. And keep it 2 and close. Now we have to use the command which was given in this tutorial. So I use this here. So now we open this command. Before doing this, we have to type this decomposePar. And once done, you go with this command mpirun to process. The case is running on 2 processes now. So once the parallel run is done, there are 2 processes. We need to reconstruct them. Now once the simulation is done, we have to reconstruct the results. So use the command reconstructPar. It will take some time. The reconstruction is done. So we will see the results in the folder. So the results are updated. So now open the ParaView again. Again, go to 0 folder, copy any file here, paste, then rename as case. Okay, then browse for the parallel mode. And here is the case. So this is a domain. Then we create a section. This is the velocity. This is the U magnitude. Then we can create the animation. save animation, same folder, file name you have to give. Then we go file type as AVI. Okay. Okay. In frame rate, we'll give as 5. Yes, good. Okay. So done. So other results may be extracted accordingly. So this is it.